Radical expressions are a relatively minor ACT topic, shows up on between 25 and 50% of tests, usually one question only. But the skills that you use when you do radical equation questions often show up in other places. You need to know how to get rid of powers, including radicals. So I picked a question for this video that has a fraction as well as a radical to illustrate a couple things. One is when you're dealing with radicals, you usually have a bit of an option when to get rid of the radical. If you're dealing with just a radical equation, no fractions, it's usually best to get the radical all by itself on one side, get everything else on the other, combine it as much as possible, and then square or cube or whatever every single thing in the equation to remove the radical. But when you have fractions, which is actually kind of often the case on higher number radical equation questions, they'll combine radicals and fractions. You have more freedom in choosing radical first or fraction first. Now, when I look at this problem, I see two fractions equal to each other. And if you watched a bunch of my videos or you've had the fortune or misfortune to meet me on Skype, you know that I'm a big cross multiplier. Love proportions, love cross multiplying. So automatically when I see this, I think cross multiplying. Bottom to top, top to bottom, bottom to top. X times square root of 5 times 2 times the square root of 5. Well, that's 2x. And then that's square root of 5 times square root of 5. That's square root of 5 squared. The square removes the 1/2 power. So I have 2 times x times 5, which is a silly way to write it. But 2 times 5 is 10. I'd have 10x. If you're a little iffy on your powers, check out the stuff on multiplying and dividing exponents and look at that, because that'll help you figure out how I remove that power, both in the book and in the videos. Now let's do this side. Square root of 5 times 10 is, well, that's 10 times the square root of 5. I want to get the x by itself, of course. Divide by 10. Divide by 10. 10's cancel on both sides. X is equal to square root of 5. Very simple. I didn't have to take anything to a power. It just kind of worked out really nicely. Let's talk about another fraction first way to do this one. You know, and to be honest with you, when you have radical expressions and fractions, it's usually easiest to do get rid of the fraction first, but it's not always. And what you prefer and what you feel comfortable with may be very different than what I typically feel comfortable with. So these are very flexible problems. As long as you follow the rules of algebra, you'll get to the right answer. You just don't have to go the same route that I go. So I want to show you 3 ways to do it. We already did the first. This one is another fraction first way. And then the third way will be exponent first. The other thing that kind of occurs to me, but to be honest with you, didn't even occur to me except after cross multiplying, is that I've got fractions that could easily be simplified. Square root of 5 and square root of 5, they're both factors in the numerator and the denominator of this left-hand fraction. They're not being added, they're not being subtracted, right? So that means I can cancel them. So that cancels down to 1, 1, and that just leaves us with x over here. X is equal to 10 over 2 square root of 5, which by the way is an answer, right? X is equal to this number. That is a valid answer, but it's not as simple as it needs to be because we don't have an answer choice that has this. So do it in pieces. This is kind of intimidating. You can do this in a calculator if you wanted, but I would think 10 divided by 2 is 5. So I would have 5 over the square root of 5. And this is a point I really wanted to get to. When I divide a number by its square root, so let's say I have 4 divided by its square root is 2, the answer will be the square root. 4 divided by 2 is the square root of 4. 4 divided by its square root is its square root. 9 does the same thing. 9 divided by 3 is 3. 25 divided by 5 is 5. So 5 divided by square root of 5 will be the square root of 5. So second way we got there, just as fast if you're really comfortable with it. Not a ton of steps, fairly straightforward. Now let's talk about getting rid of the radical first. I said this kind of towards the top of the video, but whenever we want to get rid of a radical in an equation, we have to do it by squaring. And we have to square every single thing in the equation. Leave nothing unsquared. So square, square, right? So we can distribute this square. It's not really distributing it, but it feels like it because I don't have terms. I don't have binomials. If I had a binomial, x plus 1, I'd have to FOIL it. Check out the video on expounding for more on that. So this would give me x squared. Square root of 5 squared is 5. So 5x squared, square root of 5 squared is 5. Again, these will cancel. 10 squared is 100. 2 squared is 4. Square root of 5 squared is 5. 100 over 4 times 5. So x squared equals 100 over 4 times 5, or 100 over 20. Divide 100 by 20, x squared is 5. Square root both sides to just get an x. X is equal to the square root of 5. Third way to get there. So figure out what you like best. Spend some time on these in the book if you don't feel very comfortable with radicals. Not as much for the actual radical questions themselves, but for the stuff that actually uses those principles. It can be really, really handy. You'll see a lot of plug-in problems that that sometimes I have a tough time deciding whether it's really a plug-in problem or it's a radical expression problem. So tougher elementary algebra plug-in problems often use these skills. You know, of course, you can also say they or show up in trig, in the distance formula, circle formula, other places as well.